Thank you, everyone, for joining us for another episode of the Gold Silver Bitcoin Show, brought to you by the GoldSilverBitcoin.com store. We are more than honored today to be sitting down with Dr. Avi Loeb. He's an Israeli-American theoretical physicist who works on astrophysics and cosmology. Dr. Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University. You also recently sat down during a fireside chat with Eric Weinstein at Bitcoin 2022. Thank you so much, Dr. Loeb, for joining us today.
Thanks for having me. It's a great pleasure.
Pleasure is all mine. So I think I want to start very broad because I think that is probably the best way to bring in the broadest range of people into this discussion. And you made headlines, I believe in 2020, claiming that aliens exist and are in fact amongst us. Can you clarify these comments, please? I'm sure you've done it before, so you can give us the Cliff Notes version.
Right. Well, I didn't really claim that aliens are among us. That was an interpretation. Basically, we discovered the first objects over the past decade that came from outside the solar system. You might expect those to be comets or asteroids of the type of objects that are naturally produced and that we studied before in the solar system. But the first reported such object was Oumuamua, and it was discovered from the reflection of sunlight off its surface as it passed through the orbit of the Earth around the sun. And astronomers discovered it by chance. We didn't expect it to be there. It was roughly the size of a football field. And of course, the initial assumption was that it's a comet, because these are the most common objects that have ice on their surface. And when they come close to the sun, they evaporate and create a cometary tail of dust and vapor that we can see. And the only problem is there was no cometary tail around this object, so it was definitely not a comet. And in fact, the Spitzer Space Telescope looked very closely at this object in the infrared and put very tight limits on any carbon-based molecules surrounding it. So definitely not a comet of the type that we're familiar with. And then this was the first object from outside the solar system that we knew about, and it started to appear very weird because as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10, and that meant that it has an extreme shape, and the most likely fit to the variation of light was that of a pancake shape, a disc-like object. Then it was pushed away from the sun by some additional force, a mysterious force, and the only explanation I could give for that was the reflection of sunlight is pushing it, because there was no cometary evaporation, no rocket effect pushing it. And so for that to be effective, the object had to be very thin and flat. And nature doesn't make such things. So I raised the possibility that it's artificial in origin. And that was the first object reported from the reflection of sunlight. We could only see objects the size of a football field over the past decade, and this is the first we saw. And then with my student in 2019, a couple of years later, I was asked to be interviewed for a radio station about a meteor that was seen over the Bering Sea off the Kamchatka, near Kamchatka. And I went online to read more about meteors. I saw a catalog of meteors that the government publicized, where they put the data from either space-based sensors or ground-based sensors that are used to monitor objects in the sky, as a missile warning system. And they provided data on meteors because these are of astronomical interest. So I went to my student, Amir Siraj, and asked him, could you please check whether the fastest moving meteors in this catalog could be from interstellar origin, from outside the solar system, which is a relatively straightforward thing to do, because you take the three-dimensional velocity of these objects and figure out whether they're bound to the sun, okay, after you take off the motion of the Earth from this. And he looked at the fastest object. It turned out that it was a head-on collision with the Earth, so it was moving exactly opposite to the Earth, and it could be bound to the sun. But the second fastest ended up being unbound to the sun. And actually, if you were to extrapolate it back, it was moving at nearly 60 kilometers per second outside the solar system, very high speed. So we published a paper, and then it was not accepted for publication because the reviewers argued, well, we don't believe the government, they didn't release the uncertainties in the measurement. And obviously they didn't release the uncertainties because they were obtained by classified sensors. So the government doesn't want adversaries to be aware of how well we measure the motion of objects in our sky. Anyway, it took 3 years for the government to come out with a statement, which came out just over the past couple of weeks, saying in a letter, a formal letter that was tweeted and publicly advertised, that indeed their data is of very high quality, and they can confirm at the 99.999% that this meteor came from outside the solar system, okay, based on its high speed, which is the original claim we had with my student in 2019. Now, why is that significant? It's significant, first of all, because the meteor has roughly the size of half a meter, so it's much smaller than a football field, the size of Oumuamua. So we are probing objects that might be much more common. If you assume a random population of such objects, there should be 1 million of them within the orbit of the Earth around the sun at any given time. It's just that the fishing net of the Earth colliding with one is very small. So, every few years we collide with one. But the second most important thing is when a meteor burns up in the atmosphere, it produces a fireball, and then the debris, whatever is left from it, lands in the ocean or on the ground, depending on where it fell. And this one was off the coast of Papua New Guinea, and the debris, the fragments from it fell on the ocean floor there. So we can go there and study those fragments and learn about an interstellar object. Now, just half an hour ago, we submitted a paper where we analyze the fireball light curve. Now, this light curve was released by the Pentagon as a result of an agreement with NASA in 2020. They decided that they will release data on the light curves of meteors. And that was part of the package associated with the release also of the confirmation letter that says that our meteor is interstellar. So we went to that light curve that they released just last week, okay? And we analyzed it. It basically shows 3 flares in the meteor in the fireball as the meteor burned in the Earth's atmosphere at an altitude of about 18.7 kilometers, okay? And what we inferred is, in order for it to burn at 18.7 kilometers and not much earlier, it had to have a very tough composition, a very strong material to sustain going through the atmosphere down to this depth. And it turns out that the yield strength of the material that it was made of had to be stronger than iron meteorites. So just think about it, strong, tougher than iron. We don't know what it is. We have to go to the coast of Papua New Guinea and have an expedition into the ocean floor, which we are planning to do. The depth of the ocean is 1.7 kilometers, and we are currently planning this expedition. But metaphorically, and I just wrote a commentary about that before I joined you, metaphorically, it's similar to expanding our island of knowledge in the ocean of ignorance that surrounds it. So, we can use evidence to guide us as to understand why this object was so anomalous, this meteor, in terms of its composition, what kind of composition it had, whether it was natural or artificial in origin. The 2 objects that I mentioned, Oumuamua at first in 2017, and this meteor from 2014, which predated it actually, the detection of it was 4 years earlier than Oumuamua. Both of them are quite strange, anomalous, and that raises a possibility that we might revise our conventional wisdom, the way we think about our cosmic neighborhood.
The paper you just submitted this morning, the paper on the fireball light curve, What is the significance thereof? And is there any more details you'd like to share?
Yeah, so it's quite interesting. So if you believe the government data, okay, so there is always a possibility that somehow, the data is incorrect. There is all, and that's true also for scientists. When an astronomer reports about a transient event, you have to believe them. And I believe the government simply because, the sensors were developed for national security purposes, and they must be very precise. You need to know whether a ballistic missile is heading towards Boston or New York City. You need to know it quite precisely. So if they get the numbers wrong for meteors, they should really, they're not doing their homework, okay? So if you take it at face value, the data that was released by the government, what we find is that the meteor was moving at 44 kilometers per second when the fireball was detected. That was at an altitude of 18.7 kilometers above ground, above sea level. And we know the air density at that altitude. So we can calculate the ram pressure, which is basically the force acting on the frontal surface area of this object per unit area, per unit. Basically, there is friction with the air, okay? And the friction depends on the air density times the velocity of the object squared. That's it. So we have a measurement of the speed of the object, and we know the air density at that altitude. So we can calculate how much pressure is exerted on the object. And from that, the material strength needs to exceed that pressure, because otherwise the object will disintegrate. And that's what happens in the fireball. That's when the object disintegrates. So we can tell up to which point the object was able to sustain its integrity, okay? And that tells us how strong the material was. It's called the yield strength. How strong does it need to be so that it's not being deformed or ripped apart, as a result of the pressure acting on it. And what we find is that the stress is pretty high at that altitude, at that speed, and to the level that it's twice as large as solid iron. If you just take solid iron, it won't sustain the ram pressure that I'm talking about by a factor of 2, okay? And if you take stony meteorites, rocks that we often see from space, that most of which are just from the solar system, if you just take a rock, it's off by a factor of 20 or more. So obviously a rock would disintegrate much earlier. Not to speak about the explanations from the mainstream of the astronomy community for Oumuamua. So people suggested these anomalies of Oumuamua could be explained if it's made of a hydrogen iceberg or a nitrogen iceberg or a fluffy cloud of dust particles. Okay, these were the alternatives to the artificial origin that a lot of people in the mainstream of astronomy embraced. Okay, so if we take those for the meteor, the meteor would never survive going through the atmosphere. It's obviously none of those. Hydrogen, nitrogen, or a fluffy cloud of dust particles would not get down to an altitude of 18. It would have burned much earlier. So here we see an object, the second one from Interstellar, actually the first one, because it's 2014, the time that it was discovered. Before Oumuamua, that was 2017. And we can say something about its composition from the fact that it survived down to 18.7 kilometers. And that's what our paper is talking about. And the other thing that our paper did was calculate the slowdown of the object in the atmosphere. So we detected the fireball at that altitude, but it came, the object came from above the atmosphere. So you can ask, how much faster was it moving when it entered the atmosphere? Because it was slowed down as it went through the atmosphere. So it turns out that it was moving faster by about 50%, about 22 kilometers per second faster than the 44 that was reported. So that actually strengthens the case that it was interstellar. We already, from the 44 kilometers per second detection, demonstrated that it should have originated from outside the solar system because it's unbound to the sun. If you add to that the 22 that it was slowed down by until the point where it was detected, you get a very clear indication that it was interstellar in origin. But moreover, it's an outlier in terms of its speed, because most stars move relative to the local, it's called the local standard of rest, which is sort of the frame of reference that you get to when you average the motions of all the stars in the vicinity of the sun. It's sort of like the local parking lot, okay? And so most stars move at up to 30 kilometers per second relative to that frame. And this object, without the correction for the slowdown, was already moving at 60, which is twice as large. And with the correction of the slowdown, it's more than that. So you're talking about an outlier object that is moving twice or three times faster than the stars are relative to the local standard of rest. Okay, so if it was ejected naturally, if it was like produced naturally, it needs to be ejected very close, in a very deep potential well, very close to a star, you know, inside, for example, the orbit of Mercury, which is the closest planet to the sun, because Mercury moves around at about 50 kilometers per second. And if you want to eject an object with a characteristic speed that is bigger than 50 kilometers per second, it needs to come really close to a star, because otherwise, if it's far away, it cannot get a kick large enough. So if it's natural, it had to originate very close to a star, you know, and that's unlikely because most objects are far away. And then the second point is, if it's artificial rather than natural, then of course it could be propelled artificially if it's a piece of equipment, you know, if it's a craft. So altogether, I would say this meteor and Oumuamua present anomalies. Now, the advantage of this meteor is we can go and search for its fragments, you know, and we can put our hands on them and bring them to laboratories and examine them. So I think that's fascinating. That's amazing, actually, and it's very exciting.
What have been, and you mentioned this a little bit, your colleagues' reaction to the extraterrestrial explanation? You mentioned they pushed back on it a bit. Can you elaborate more thereupon?
Well, there was a colloquium at Harvard about Oumuamua, and when I left the auditorium together with a colleague who worked on rocks for decades, he said, "Oumuamua is so weird, I wish it never existed." Now let's think about it. When a scientist is presented with an anomaly, with something unusual that doesn't quite match up to what you expect, the scientist should be thrilled, because it's an opportunity to learn something new about reality. So why would someone say, I wish it never existed? The only reason is if that someone regards himself as an expert and sees any new knowledge as a threat to his expertise, in the sense that he pretends to know everything that is possible about any object in the sky. He gets his reputation from studying rocks in the sky, and therefore would argue that anything we see in the future must be a rock. Why? Because that's the way he gets his reputation and image and promotes his chances of getting awards, recognition, and appreciation for his expertise. But if this is something different than a rock, that poses a threat. It also poses a career risk, because maybe it's not a rock, maybe it's a rock, but if you suggest that it may be artificial, then you are at risk of being wrong, which you don't want to take. So, so that explains this attitude of rejection for anything unusual. But there is also the sense that, you know, we scientists feel happy about dealing with the laws of physics that apply to atoms. You know, we discovered them in laboratories, and atoms throughout the universe follow the same laws of physics, okay? At the edge of the universe, an atom, you know, it can be described by the Schrodinger's equation, you know, the quantum mechanical description that we have here on Earth. Now, that gives us a sense of superiority because we are smart. You know, we can figure out how everything in the world, in the universe works. And we feel that we have free will. We are intelligent and have free will. So we don't need to obey laws the way an atom does. And we feel superior because we control the atoms. We can make whatever we want out of atoms. We can make gadgets. So that gives us a good sense first that we are smart, that we can figure out how atoms operate, and also that we can use them for our purposes, and we have free will. You know, people do not obey societal laws all the time. That's why the court system is around. And so in a way, we are different from atoms that have to obey, that they don't have free will. So that is fine for a scientist. And then the next step is to say, okay, maybe there are microbes on the surface of Mars. So we can send the Perseverance rover to study microbes on the surface of Mars, may have existed billions of years ago. If we find evidence for that, it will not hurt our ego. Why? Because microbes are not as intelligent as we are. So we would still feel good about it. Okay, as scientists, we discovered something interesting. Mars had life on it, but it's microbial life. We are still at the top of the food chain, But imagine the Perseverance rover running into the wreckage of a spaceship that represents technologies far more superior to what we possess on the surface of Mars. That would be a blow to our ego. Nobody would like to entertain that possibility. So dealing with the possibility that we are not the smartest kid on the block is problematic because it hurts our ego if that's the case. And we might prefer not to know about it, just the way that philosophers during the days of Galileo didn't want to know that the sun moves around the earth, because it's much more flattering to our ego to think that the earth is at the center of the world.
We've seen also images play out on television over the last couple of years. There being sightings off of the coast of San Diego by Navy pilots with claims that these the objects or planes objects have capabilities that are far more advanced than our own. What are your thoughts on some of these, I guess, events, phenomena?
So I think it's intriguing enough since the government is establishing an office that will start operations in about a couple of months, June 2022, on this subject, collecting evidence from all sections of government, assembling them and analyzing them. So that's, that shows that at least the government thinks it's a serious matter, that it's not part of the routine charter of the intelligence agencies to figure out what adversaries or other nations are doing, right? Because if it was part of that, you will need to establish a new office. So it looks as if the government is puzzled by some objects that are not obviously related to human-made objects or to natural phenomena. Now, that doesn't mean that indeed it's not natural or human-made. It only means the government is puzzled, okay? And that's the point where scientists should engage and figure out the answer. And that's because the sky is not classified, you see, most of the sky. So that led me to establish the Galileo project. And it has two primary goals. One is to figure out the nature of objects like Oumuamua or this meteor, okay, by taking a close look at them, taking a high resolution image or analyzing their composition in the case of the meteor. And they say a picture is worth 1,000 words. In my case, it's worth 66,000 words, the number of words in my book, Extraterrestrial, that I wrote about Oumuamua last year. And the second goal of the Galileo project is to build telescope systems, new systems that would monitor the sky and figure out whether there are objects that are unusual, that are not natural or human-made. And for that, we build new telescope systems because existing astronomical observatories are not doing that. And in fact, we plan to assemble the first system on the roof of the Harvard College Observatory in the coming months, and then deploy copies of this first system in different locations. And the number of copies we make will depend on the level of funding. So with the current funding of $2 million, we can make maybe a few copies, but we hope to get to $100 million and then have hundreds of copies in many locations. That would allow us to get to the bottom of the question of what does the government see? Okay, so that's really what we want to address. And $100 million is not a lot for a scientific project. If you think about the biggest science projects, like the Large Hadron Collider or the James Webb Space Telescope, they are 100 times more expensive at the level of $10 billion. And here we're talking about 1% of the cost of these expensive projects. So for 1% of the most expensive scientific projects, we can figure out the answer to a question that is of great interest to the government, of great interest to the public. And that's what we plan to do in the Galileo project.
What would the implications be for, I guess, Western civilization or certain nation states, et cetera? Not if these were extraterrestrials, because I think that question is asked so often, but rather, what if some of these technologies that have been claimed to have been observed, as far as I know, there's images on my television or on the internet, were actually terrestrial?
Oh, so that's valuable as far as I'm concerned as well, because at the moment the public speculates, the government speculates, right? And if in our scientific research project of the Galileo project, we figure out that all the objects we see are either natural or human-made, so be it. It's a fishing expedition, and I think we are doing an important service because we are clearing up the fog. Instead of assuming that they might be extraterrestrial, we will figure out that we don't see anything beyond things that we are familiar with. So I think that's very important. That's useful to society, rather than saying, ridiculing the subject like a lot of my colleagues are, and ignoring it and leaving the questions open in the mind of the government and the public. So I think we should clear up the fog. And there is a chance, that this fishing expedition will capture something rare. And the point is that even if we see one object out of the many, it may be a mixed bag, right? But even if we see one object that must be extraterrestrial because it behaves in ways that our technologies cannot reproduce, and it cannot be natural because we see the screws and bolts on it. We might even read the label saying made on exoplanet Y, And if we have such conclusive evidence, then that will change the future of humanity. So I think it's a risk worth taking, in the spirit of what, and I say that in my book, in the spirit of what Blaise Pascal, the French philosopher, mathematician, said. He said that, we don't know if God exists or not, he said, but the implication of God existing are so great that we must consider that possibility seriously.
I agree with that statement. I think oftentimes we get dismissive of that which we don't believe ourselves. And I think that has a degrading effect on society.
Well, one thing I should add is that, the abilities that we assign to God in religious texts may very well reflect the abilities of an advanced scientific civilization that can create life in its laboratories, perhaps create universes in its laboratories if it understands how to unify quantum mechanics and gravity. So what I would say is we might be at O if the technological gap between whatever equipment we find in space and our own technologies, if that gap is huge, it would look like magic to us.
On that topic, you were quoted at Bitcoin 2022 as stating, quote, "The breakdown of Einstein's theory of gravity may allow an advanced scientific culture to do things that look like magic to us." Can you expand on that thought?
Right. So it's all about the gap, okay? Mind the gap, which is the technological gap between us and them. Now, we developed our technologies only over the past century. If you think about it, quantum mechanics was discovered a century ago. And now all the gadgets that we used are based on that knowledge. Just a century-old knowledge. So imagine a civilization that had technology and science for 1 million years or 1 billion years. It's difficult to even think about what it might be able to do technologically or scientifically, as long as it can survive, because we are not very careful at how we handle our environment. Some people go to wars, and there is a risk that we might not exist in a few centuries from now because we are not careful enough. But if you can imagine us surviving for 1,000,000 years, then the kind of world that we would live in would be unimaginable for us right now. Okay, it's sort of like a cave dweller going to New York City, okay, and seeing all the gadgets there. It will become part of the myth of the cave dwellers when that person goes back and reports about it. They will never be able to reverse engineer what that person sees in New York City. So my point is, if the technological gap between us and them is huge, as you would expect from a civilization that had 1,000,000 years to develop their technology, then we wouldn't be able to reverse engineer what that we are seeing. We wouldn't be able to understand it. Just to give you an example, most of the matter in the universe is called dark matter because we don't know what it is. It's not the ordinary matter that our body is made of, that the earth is made of. It's something else, something that doesn't interact with light. We don't know what it is, and that's 5 times more abundant in mass, in the mass budget of the universe, than ordinary matter. So we are made of rare materials. Most of the matter is something else. We don't know what it is. Now imagine another civilization that is more advanced than we are, that figured out what the dark matter is. Okay, we don't know what it is. They figured it out, and they play with it. They can engineer it somehow. And if you were to see a spaceship with nothing coming from its exhaust, just because of the fact that they're using dark matter as the rocket fuel, you would be shocked. How is it possible for it to propel itself? I don't see anything coming out. Why? Because it's dark matter. We can't see it with light. So just to give you that example, and of course, we also know that the universe is expanding at an accelerated rate. And that means that the vacuum also has some energy density to it. So if they learned how to excavate the vacuum energy, it's very abundant, it's everywhere. You can use it for whatever you want to use it for. And what I'm saying is we have holes in our knowledge that if someone else figured out how to use these holes for engineering purposes, we might not be able to figure out what we're seeing, from them. So to me, it's a learning experience. I think we should be modest, humble, and just collect evidence before we jump to conclusions. But instead, a lot of us prefer to believe we're the smartest kid on the block. That's not very different from my daughters when they were young and they stayed at home. They thought they are the smartest because they compare themselves to the family members. And of course, once they went to the kindergarten, they had a psychological shock to see smarter kids on their block. So, my lesson from that is we should look through our windows to see whether we have neighbors and learn from them, because for 2 reasons. First of all, it will change the way we perceive ourselves, but second, it would also allow us to gain knowledge, to learn from them. And by that, we will save time, because it could bring us to our salvation in a way, because we will learn things that we haven't figured out yet.
I was experimenting the other day very briefly, didn't come to any conclusions I'd put down on paper about what it would be like if Plato or Aristotle found themselves in the present day, and the learning curve even they would experience. And then also your comments made me think that perhaps the dark matter in our universe would be better referred to as dark matters. I know nothing, I'm a layman, but
it's possible that it's a mixed bag. But the most important thing that I wanted to say is that we should be guided by data, by evidence about nature, by experimenting with nature, by collecting as much knowledge from nature itself, rather than assuming that we can figure it out in a closed room, out of pure thought. Even though it's much nicer to think that you can figure out the world, or to put goggles on your head and live in the metaverse. That's another option we can do, just not learn about the reality we live in and be illusioned But that's no different than the philosophers who refused to look through Galileo's telescope because they wanted to live in the virtual reality that we are at the center of the universe. And I am actually I feel much more satisfaction from learning about the reality we all share, because I want to see the pimples on the face of reality, you see, rather than any makeup that hides those pimples, that makes us more important. Just because we refuse to look through our windows, just we can think that we are the smartest species that ever existed since the Big Bang. And my point is, Albert Einstein was probably not the smartest scientist over the past 13.8 billion years since the Big Bang, because we know that about half of the stars, like the sun, have a planet the size of the Earth, roughly the same separation. And if you just think about the billions of other planets that formed, billions of years before the Earth, that had similar conditions on their surface, I would argue that it's very likely that the smartest scientists lived before Einstein, billions of years before Einstein. And that allowed the civilization of that scientist to send probes that would reach us by now, even if they move at the speed of chemical rockets. So why not be modest? Let's assume that we are not special or unique. That's what I tell my students at Harvard on the first day of class. I say, half of you in the class are below the median. And that's a statistical fact. The median is defined such that in any class, half of the students are below the median. Now, at Harvard, all the students prefer to believe that they're at the top 1%. So for them, it's a shock to realize that half of them, in any class, half of them are below the median. And that's my message to our civilization, okay? Just like Harvard students, don't feel that you're privileged, unique, and special. Just assume that you're sort of in the middle of the distribution, and let's search for others that might be smarter than us.
That's kind of what I'm doing with this show, I suppose. Dr. Loeb, so what is the cross-section, the intersection between cosmology, natural science, and astrophysics?
Well, okay, so cosmology is about studying the universe, the biggest system that we know about. It's sort of the stage on which the cosmic play is taking place, and we tend to think that we are the main actors, that everything is centered on us. We are privileged, unique, and special. We're at the center of the stage. But the fact is that we arrived relatively late, in cosmic history. The universe existed for 13.8 billion years. We just arrived recently in cosmic terms. And, we have no reason to think that the play is about us. It's very likely that there are other actors, and they know more about, the universe than we do. So cosmology studies the properties of the universe. And I must say, we have been doing that for 100 years now. And we're pretty ignorant, despite of what you hear from my colleagues. Just to give you an example, we don't know what most of the matter in the universe is, and we get paid as cosmologists. That's amazing. How can we get paid to discuss something we have no clue about? We should be modest and humble in admitting that we really don't know what most of the stuff in the universe is. That's amazing. For 100 years, we've been studying it. That's called the dark matter. And dark energy is the vacuum energy, which is causing the accelerated expansion of the universe. We still don't understand both of them. And then other than that, we can say, okay, well, if the dark matter is made of particles that are sort of relatively cold when objects are like galaxies are starting to be formed in the early universe, then we can figure out what happens, and it looks pretty similar to the universe that we see. Okay, so we can sort of get a sense, and we can understand how stars are formed and how a star like the sun was made, and out of the debris that was left behind, the formation process of the sun, whatever was left behind made building blocks that made the planets. That Earth represents one of them. And so we sort of understand how we came to exist. So that's the story of cosmology. There are still missing photos in our photo album of the universe. For example, how the first stars were made. That's what the James Webb Space Telescope is intending to find. And that's a subject I worked on for decades. It's the scientific version of the story of Genesis. Let there be light. Okay. So cosmology is all about our history, how our cosmic roots, how everything started and made what we see around us today. And we have sort of a sketch of that, but we still don't know what the constituents of the universe are, okay? Like the dark matter, the dark energy. And then the second subject you mentioned was astrophysics, was it? Or what was it?
Yeah, natural sciences and the way they
Natural
connect with Bitcoin.
Okay. So natural sciences are, include physics, mathematics, statistics, biology, chemistry, and all of these. And fundamental to the natural sciences that deal with reality, not to mathematics is sort of abstract constructions that are very helpful in pursuing our understanding of reality, but mathematics is not about reality. It's about logical structures that we can construct in our head. The physics, chemistry, biology are all about the real world that we live in, and it all boils down to what we understand about physics, because that explains the physical reality that biological systems are made of, that chemical systems are made of. And so it's quite striking, I should say, that over the past century, we were able to do experiments in our laboratories and learn about the laws of physics, meaning how the elementary particles behave, how do we describe them? And just from learning based on laboratory experiments about how the elementary particles are operating, we were able to understand how the universe operates. So, it started with Einstein's theory of gravity, and then quantum mechanics, and then, everything that followed. By now, we have a comprehensive understanding of the universe, except the constituents of the universe. But when we see atoms at the edge of the universe, they behave the way that our laboratory atoms behave. So that's a remarkable achievement, that we're able to explain things that are very far away, that happened very early on in the universe, using what we learned from laboratory experiments here on Earth. And it's also striking that the same laws apply everywhere. So two things. One, that we were able to figure it out just from local experiments here. We were able to figure out what happened early on in the universe and far away. But moreover, that we can do that it's not like a completely chaotic universe where, every other region has its own laws of physics, which could have been the case. If you think about societies on Earth, they have different laws that govern them, and people violate those laws. They are judged in courts, they are put in jail. So when you decide about laws for behavior of humans, they are not universal, okay? But however, nature respects the same laws everywhere. That's amazing, that. So that's what natural sciences are about, using what we understand from physics, then to the benefit of chemistry, how atoms interact and make molecules, and then how those molecules make living organisms in biology, and so all of this constitutes what we now call natural sciences. And of course, we need mathematics for that, and the tools of mathematics are extremely helpful. And then what was the third component that
I suppose astrophysics?
Astrophysics is more about anything we find, in the universe, so to speak. So cosmology is about the big structure of the universe, how it expands, how it started, how structures started to form in it. Astrophysics is about everything in it, including stars, how stars burn their fuel. Stars are just nuclear reactors, but they're held together by gravity, and they fuse hydrogen atoms and helium atoms. They fuse them to produce energy. And stars were just they formed out of clouds of gas that condensed by the force of gravity. And then, these regions that made the stars condensed the gas so much that it became hot enough to have nuclear reactions. And that's what a star is. So it's just the condensation of gas into a compact region, such that the temperature in the middle is so high that it burns nuclear fuel, like a nuclear reactor. And then when it burns the fuel, that produces enough pressure to support the star against collapse. And that's what you see as a star. It's basically a nuclear reactor producing energy that gets radiated, and we see it as the light coming off the star. And then the star has a lifetime. The sun is roughly at the middle of its life right now. And within 1 billion years, it will expand and burn everything on the surface of Earth. So we will definitely need to leave Earth in 1 billion years, maybe even before. But the point is that stars, they have a life. The massive stars live very shortly, and they explode in a big, supernova explosion, and some of them collapse to make either a neutron star or a black hole. And the other thing I should say is it's not all about light, because 7 years ago, the first signal from a collision of two black holes that came together created ripples in space and time that we detected across the entire universe. These are called gravitational waves. It's a completely new way of looking at the universe that does not involve light. So astronomy, traditionally, astrophysics was about the physics of astronomy, trying to figure out using mostly light. But recently, over the past 7 years, we've been using gravitational waves to study the universe as well. And we are using other particles like neutrinos, cosmic rays to study the universe. So I would say by now we have many messengers that tell us what happens far away. And that's all part of astrophysics.
So we need to leave the planet at the latest in 1 billion years, when the sun expands and burns everything on the surface. So now, do you end up at a conference like Bitcoin 2022 because you believe that Bitcoin is a technology which could support such endeavors?
Yeah, that's one reason that I'm trying to make the case that there are very exciting questions that science can address. And unfortunately, it's not addressing using the conventional funding channels. You see, if you go to NSF or NASA and ask, and I actually tried that, and ask to fund a search for objects whose nature is unclear, either in the atmosphere or in space, you would not get it, because the committees that decide how to allocate the funds, they do not take risks most of the time. And therefore, it's the private sector. And, a few multi-billionaires visited the porch of my home after I published my book, and they were inspired by the vision. That's how the initial funding, seed funding for the Galileo project started. But we need more. We currently have $2 million. We need 100 million. So that's one reason for me to appear at the Bitcoin conference. But there is another, which is more important, perhaps, that, Fix the Money is all about decentralization of, the money, the monetary system, and not allowing the government to control it. And in the context of these unidentified objects in space, the narrative was controlled by the government that has classified data to which we don't have access. Okay. And so here we get to a point where this data is of interest to scientists. And science is all about sharing data openly. And that argues that the knowledge should be decentralized. Okay. And that's what the Galileo project is doing, trying to collect our own data. And in a way, this intellectual theme, this idea of decentralizing what we can do, not allowing the government to control what we know, is the theme that I'm pursuing with the Galileo project. And that's, I think, the more important reason why it was important for me to appear in the Bitcoin 2022 conference, because we share the same goal of, in my case, decentralizing knowledge so that government will not control knowledge that was collected by classified data and therefore is not shared openly. We will share our knowledge openly, and I don't want classified data because I will not be allowed to share it openly if I knew it. And at the same time, Bitcoin is promising a future in the monetary system that is also, follows the same logic.
I guess on the monetary system, well, certainly first and foremost, like decentralizing knowledge, I think Bitcoiners come from a philosophy in which they want to decentralize, I suppose you could argue, power generally, and that certainly includes knowledge. it's been expressed, Satoshi Nakamoto, whoever they may be, through the monetary system, through a monetary mechanism. Can you speak more about Bitcoin in the context of the monetary system and what your views are thereof?
I think it's a very promising future that is being offered by the idea of Bitcoin, in the sense that it also follows ethics in a sense of not allowing people to manipulate the system for their own benefit if they're in position of power. Just like, real if you have possession of something in the real world, then its existence cannot be doubted by people in power. If you possess a barrel of oil or some chunk of gold, and having Bitcoin in a way represents an asset that is avoiding the possibility of unethical use of it, okay, just because of the verification system and the fact that anyone can in principle access it. So I think in that sense, I'm very much in favor of a future dominated by Bitcoin rather than the current bank-controlled, government-controlled system. And it also offers advantages in terms of moderating inflation and allowing a more universal system across nations. You see, because if you just look at most of our political problems, it's because of conflict of interest of nations. And if you have a monetary system that avoids that, perhaps it would moderate the waste of resources on wars, that we often have, because it will be more global.
Dr. Patrick Byrne, who admittedly is a controversial figure, has given speeches dating back to approximately 2014, where he argued about Bitcoin as a advent or phenomenon of Western civilization, of a tradition of classical liberalism, etc. And in this tradition, there's a lot of skepticism regarding the nature of power. So we can look back into the pre-revolutionary times in the United States and read some pamphlets. There was a lot of pamphleting that was going on. I guess it was the pre-internet version of blogs. You'd produce pamphlets and pass them out, I believe, in town squares, etc. And so Jonathan Mayhew, for instance, saw power as grasping and encroaching in nature. If at first it meets with no control, it creeps by degrees and quick subdues the whole. While at other times it is, quote, like a cancer. It eats faster and faster every hour. Power is, quote, restless, aspiring, and insatiable, and like jaws always open to devour. These are some of the thoughts. For instance, in 1764, a quote was published in the Newport Mercury, quote, power is like avarice, its desire increases by gratification. Now, by taking out the middleman in a monetary context, Bitcoiners believe that they can at least de-risk monetary systems from, I guess, corruption. Can you speak to those quotes at all?
Definitely. I mean, you see, the other thing I didn't mention is when I looked at the audience at the Bitcoin 2022 conference, it was most of them were young, and I very much align myself with young people because they are less motivated by their ego. They are more seeking a better good for the entirety of humanity, and and part of it is because they are not in positions of powers at that phase in their life. And if we can all remain youthful in our approach, that pretty much reflects my philosophy of life. And I'm basically maintaining my childhood curiosity through my science. And one of the most traumatic experiences when I was a child was to ask a difficult question, and the adults in the room, which you can think of as people that are in control of the power, the adults in the room, they dismissed my question just because they didn't know the answer to it. So then I decided to pursue science so that I can answer my own questions in a way that is sincere and is not based on power struggles, and unfortunately, even in science, there is a lot of power, being exerted by experts and people in control of selection committee, gatekeepers. So I am completely aligned with the idea that we should have a system that is not controlled by people who benefit from it, people who have the power to benefit and twist it in their direction. And that's the approach that I think the future, if the future represents, it will allow us to maintain longevity of humanity. Because if we keep going the path of the past, like having wars, having people in, we had monarchies, and now we have governments pursuing their own interests based on their whatever reasons. It could be ideological, it could be just maintaining power over territory or other reasons. Then our future will not be very promising, you see, and because we are wasting a lot of resources on those few foci of power, those people that control it. So I think altogether that the future should be different from the past. Okay, so what Bitcoin represents is the future. Okay, and the set of values that it sets, and also the fact that it's technology based. Okay, to me implies that we can shape it in a way that we want our society to look like, and then build from that, because a lot of corruption in politics and in human history is assisted by access to money. That's obvious, and if we change the money system, then we can suppress all of these bad aspects of human history.
Blockstream, which is a Bitcoin company, has created a satellite-based streaming service for the Bitcoin blockchain. So they've got essentially nodes in space. They lease bandwidth on commercial geosynchronous satellites to provide the quote Blockstream satellite service. Now, we are running out of time to get off the planet and in this interview. And can we look to something like Bitcoin as a technology that we bring with us to, say, Mars or other planets that we inhabit in the future, or rather even planets out there we may discover that are more like our own?
Well, I think space is the future and Bitcoin is the future. So they definitely will play together in our future. And the question is, how should we think about space? And one way to think that you find often is people talking about space tourism, commercializing space. I don't think about it this way, okay? Because there is no business plan to leave the solar system, for example. The only reason to do that is to seek the unknown, to learn about something we don't know, about our cosmic neighborhood. And I think it would be fascinating if we find evidence for a smarter kid on the block that we can learn from. If we go places, it doesn't need to be Mars, it could be other places, but generally speaking, we need to leave our planet. We can't just stay here for a variety of reasons. Eventually it will not be hospitable for life, as I said, in 1 billion years for sure, but much before that. And moreover, space is huge. There are so many opportunities out there. Why should we stay on this two-dimensional surface of this rock that we were born on? Forget about it. Let's go places and learn what's out there. And we might be surprised. Just to give you an example, one day my wife noticed a person on the street, and the person was looking at our home, and she was worried that it's a stalker, someone that, because I'm well known that people stalk me. And so she asked me, who is this person? I went to the street and I asked him, who are you? And he said, I lived in your home 50 years ago. Okay. He was a kid back then. And I took him to the backyard, and he said, my father buried a cat in your backyard called Tiger. And I said, well, I know this name Tiger because I saw a tombstone in the backyard with the name Tiger, but I was hoping it's not a real tiger or something bigger. And now I know that 50 years ago, a cat was buried under this tombstone. So the reason I bring this up is because, this is my home, but someone who lived, who shared this space with me 50 years ago knows more about it than I do. And so just think about if there is a smarter kid on our block, cosmic block, they might know more about the solar system than we know, just like this visitor that I had. And we should welcome visitors because we will learn more about our history from them.
Dr. Loeb, where can people find your work, like the Galileo Project and other works?
So you can Google me and find my professional website at Harvard University, where I have interviews. I have my commentaries every few days. I publish a commentary either in Medium, the Brief, The Hill, sometimes in Scientific American. And you can also find access to my latest books there. But the Galileo Project, you can just Google Galileo Project Harvard University, and there is a website dedicated to it. And anyone is welcome to contact me directly, and I'll be glad to correspond with people of interest.
We've had the honor and privilege of sitting down today with Dr. Abraham Avi Loeb. He's an Israeli-American theoretical physicist at Harvard. He's the lead at the Galileo Project, which you can check out online. Thank you so much, Dr. Loeb, for joining us today.
Thanks for having me.
And thank you, everyone, for listening.